Hello everyone, this is chapter 2, part 2. We are in the labor supply chapter. In this part, we'll study neoclassical model of labor leisure choice. And we'll talk about labor supply. We'll learn about indifference curves. And also we'll learn about the properties of the indifference curves. Okay, let's get started. So neoclassical model of labor leisure choice is the model that we were going to focus in this class. We need to build it from the building blocks, the basic concepts. Let's talk about the utility function or the term utility. In economics and principles class, we learned that in economics, utility means, I need to get some water. Utility is the satisfaction that we receive from consuming a good or service, or satisfaction we get from leisurely activities. For instance, if you're taking this class during the football playoff season, they're going on right now actually. And if you like watching American football and you watch it, let's say 2 hours, a game 2 hours or so, and you can actually quantify your happiness from that. We call that utility. It's a measure of satisfaction that individuals receive from consumption of goods or services and leisure. So for instance, I was actually super thirsty. I had a sip of water. I can actually quantify the value of that from 1 to 10. I got 10 units of utility. Okay, utility is like a yardstick. It's subjective. It depends on the person. You can compare different utilities of different people. Okay, so utility function is a function that you plug in the consumption of goods and services and number of hours of leisure in it, and then it's going to give you a number. Okay, so utility function, utility is an index. It's going to be a number at the end, right? This U is the utility function, F function of consumption of goods, and leisure time, L for leisure time. Higher utility means a happier person. Okay, so let's say there are 160, this is the fact, 164 hours per week, and I sleep, let's say 8 hours, 8 times 7, 56, let's say 64 hours I sleep. I have 100 hours left, right? Cleaning, eating, food preparation. I'm just doing general ballpark. Okay, so 100 hours left. If I had 100 hours of leisure, so I'm not working, the problem would be I would have zero consumption because I need money that I make from working. Therefore, anything I don't dedicate to leisure goes to work hours, and it brings me actually income to buy consumption goods. But overall, higher utility means happier person. So leisure increases utility. Higher the leisure, higher the utility, higher the consumption, higher the utility. However, there's an issue. The higher the leisure, your consumption goes down because you're not working to make money to earn that consumption. Okay, so let's learn about indifference curves. Indifference curve shows you the locus of points. So this is an example of an indifference curve, downward sloping, okay, convex to the origin. But before we get started, let's just put things in perspective by talking about hours of leisure and consumption. So as leisure goes up, your utility is going to go up. Okay, consumption is on the y-axis. As consumption goes up in terms of dollars consumption, your utility happiness is going to go up. So we put positive, positive. So whenever you have positive, positive, right, origin is here, you know that consumption increases, leisure increases, consumption increases, utility increases, leisure increases, utility increases. The indifference curves in this context will always be convex to this origin. These are both what we call good goods. Leisure is good, consumption is good. In the future, we're going to have some job risk, some negative aspect of the job, they are going to be bad goods. So the indifference curve is going to take a different shape. Okay. All right. So I'm giving you a little bit side information, but we are all good. Okay. So we put consumption on the y-axis. Again, guys, don't forget this. These videos do not replace the book. Read your book. Okay. Consumption on the y-axis measured in dollars. Hours of leisure is on the x-axis measured in hours of leisure. All right, so this is an indifference curve. This is a downward sloping indifference curve that gives you, for instance, 25,000 euros. That's the index, right? That's this, any point on this indifference curve, any combination on this indifference curve will give you the same level of happiness. Indifference curves are locuses of combinations of different combinations of consumption and leisure that gives you the equal satisfaction. So any point on this indifference curve gives you 25,000 euros. For instance, I'm going to call this point A. This point A is made up of $500 worth of consumption and 100 hours of leisure. That's great, actually, lots of leisure. A has that combination, right? Point A has 100 hours of leisure and $500 of consumption. This is C. This is leisure. This is measured in dollars. We put X coordinates first, Y coordinates second. Okay. If we look at another point, point B gives you exactly the same happiness level, folks. However, this combination is 400 units of dollars of consumption with 125 hours of leisure. 125 hours of leisure, right? You have more leisure. That means you're actually consuming less goods because you worked less. Sorry, you had more leisure. You worked less, therefore you're consuming less. So A to B movement is reduction in consumption and increase in leisure. So there are people like this, right? They are taking lots of leisure time and they don't consume too many consumption goods. Okay, so properties of indifference curves are they are downward sloping, indicating a trade-off between consumption and leisure. Yes, so trade-off, where's the trade-off? Moving from A to B, your consumption goes down by delta C, 100 units, negative 100. However, leisure goes up, right, by 25 units. So the trade-off is that for 25 unit of additional leisure, you're giving up $100 worth of consumption. So for one more unit of leisure, you're actually giving up $4 of consumption. Okay, so that's what it means, right? 100 units of consumption given up to get 25 hours of leisure. So it indicates a trade-off. Where's the trade-off? To actually get more leisure, to get more leisure, you need to give up consumption, or vice versa. If you want more consumption, then you need to give up leisure. Indifference curves are convex to the origin. Origin is here. Okay, 0, origin. Convex means, an easy way to learn convex is like a cereal bowl. Okay, so this is a convex, this is a concave shape. Convex to the origin means the bottom of this cereal bowl is facing the origin, which it does. Let's see, bottom of the cereal bowl, right? This one, indifference curve, facing the origin. All right, this indicates opportunity cost increase. Opportunity cost increase means, this is a microeconomics principles topic. Opportunity cost increase means to get 25, so as you let me just explain in plain English terms. Let's say I want to increase my leisure from 100 to 125. I gave up, right? To get 25 units of leisure, I gave up 100 units of consumption. Okay? That's a lot. So if I want to go ahead and increase my leisure by another 25, then I'm going to have to give up a higher rate of consumption. Okay? So I want you to understand, the more of a good, opportunity cost increase means the more of a good you consume, in order to keep consuming more of that, you need to give up larger quantities of the other good. Okay? And the last property is about higher indifference curves, higher utility levels. So for instance, this gives you 25,000 euros. This one gives you 40,000 euros. Indifference curve is actually an indifference curve map. And there's infinite number of these indifference curves that are parallel to each other. And the higher ones, they move in the northeast direction. Higher ones give you even higher utility happiness level. 40,000, let's say 50,000 euros. 60, 70, it goes up. So technically, what we want is to be in a higher and higher indifference curve. Okay? And the last properties, indifference curves do not intersect. They will not look like this. Indifference curves do not intersect. They won't look like this. Okay? Indifference curves are parallel to each other. So visit point A, you got point B. Okay, point C. Look at point C. You can actually consume more for 50 and also consume more leisure. So you jump to a higher indifference curve. Let's take a look at this point. I made it random point. So you're consuming 500 units of consumption goods, plus you're having, go down here, you're having a lot of leisure. I don't know, this is like 135. Not only you're consuming 500 units, just like as much as you did at point A, but now your leisure is greater than 100. So this is what it means to be in a higher indifference curve. Let's learn about the slope of an indifference curve. Slope of an indifference curve, folks, I'm just going to show in this graph. We went to the previous slide. So slope can be calculated at any point because it's a curve. Slope is not constant. Slope of the indifference curve at any point will be the slope of the line that is tangent to that at that point. For instance, here the slope is the line of this, slope of this line. I'm drawing a line here. Okay, slope of this highlighted line at this point will be the slope of the indifference curve. Another point, I'm drawing another parallel line here. Oh, sorry, tangent line. Tangent means touching at that point. So let's do different color. Okay. So slope of this green line will be this, will give us the slope of the indifference curve at this point B. This is, let's say, point F. Slope of this line that is tangent to the indifference curve will give you the slope of the indifference curve at point F. And at this point A, slope of this guy, tangent at this point, will give you the slope of the indifference curve. As you can see, the slope is flatter here. That means it's smaller in absolute value, smaller value. And here, slope is greater than that of F. Slope is the highest. So the steeper the indifference curve at the point, the higher the slope. Okay. Slope of indifference curve, let's learn about the marginal utility. Marginal utility, again, in principles of micro classes, we learn about this, but I would like to repeat it. Additional happiness one gets when leisure goes up by 1 unit or consumption goes by $1 worth of goods. For instance, marginal utility of consumption. I can actually measure this. I can tell you, yesterday I bought milk, okay? So I bought 2.5 gallons of lactose-free milk, and I had ran out of lactose-free milk. I'm very lactose intolerant, and I can't even use any lactose-free milk. I use Mootopia brand, which is, I think, truly lactose-free. It doesn't give me any trouble. So I consumed that, right? I bought the milk, and I drank 1 glass at night, all right, to get some protein. Marginal utility from consumption. So I drank about $1 worth of milk. It's organic, lactose free, it's expensive. So $1 worth of milk is about a glass, little bit less. Marginal utility from consumption is the happiness I experience and the nutrition satisfaction I experience by consuming one more dollar worth of milk. Okay, I could actually quantify this. I measured this 9 out of 1 to 10. Marginal utility from leisure, folks, is the happiness and satisfaction you get when you spend 1 more hour watching something you like. These days, I really like to watch a Netflix TV series called New Amsterdam. It's about a hospital. It turns out I really like hospital TV shows. And I spent about 1 hour after, late night, about like 9 to 10 p.m. I spent 1 hour, and I could quantify my marginal utility. It was 1 to 10 out of 10. So I'm just giving random numbers, but this marginal utility comes from the utility curve, just telling you how it works. So I'm very thirsty now. I'm taking 1 more unit of water. Sipping. We do it $1 worth of goods, but 1 more sip of water, or the first cup of coffee in the mornings for those who drink coffee. That's, you can quantify. That's called marginal utility. Marginal happiness, satisfaction we receive by consuming 1 more unit. Marginal utility of leisure, MLU, is positive, holding consumption constant. So you hold everything else constant. You are increasing your leisure by 1 hour, okay? It's a positive number. Marginal utility of consumption is the marginal utility of consumption, MUC. It's positive again. We are holding constant our leisure when we measure this, okay? So slope of the indifference curve is in the change in consumption divided by change in leisure. Why? Okay, because look, I have leisure here, I have consumption here. This is dollars. I'm gonna put $sign. This is in dollars, and this is hours. Okay, indifference curve looks like this. So let's say I'm moving from A to B. Okay, so consumption was here. Let's call this C0 to C1. Okay, so this is the change in this distance is change in consumption, negative number. Okay, C, this is not C, leisure 0, initial leisure, the final leisure L1. Okay, leisure has gone up. So this difference, that's a better bracket, change in leisure. This is a C, my C's look weird. Okay. So this is a positive number, this is a negative number. This is a negative number, delta C is negative. Delta L is positive. Why? Because my consumption has gone down, but I have more leisure now, okay? So the slope is delta C, right? What do we do in math? We do rise over run. Delta C divided by delta L. Slope of the indifference curve shows how many dollars worth of consumption would take to bribe this person to give up 1 unit of leisure. So basically, how many dollars worth of consumption you can give up to get 1 more unit of leisure. 1 more unit of leisure, how many units of consumption do you give up? Okay, so mathematically we use total differentiation. Again, if you don't remember calculus, it's okay. In this class I teach everything from zero, don't worry. So it comes from utility function. We're going to use total differentiation. So change in utility, right, along an indifference curve. We are in an indifference, on an indifference curve. This is U, level U, leisure consumption. Okay, so total differentiation requires chain rule, this and that, but what you do in logical terms, total change in utility is change in the total happiness divided by change in consumption. So when you change your consumption by a certain amount, how much is it going to change your total happiness? This is marginal utility of consumption. Okay, so this, fancy. What is this thing? This is delta. Okay, delta. Delta, we use it in terms of change, but in more continuous form. So I don't want you to be scared of all this terminology, hard things. Don't worry about it. Change in happiness, utility, when you change consumption, that is marginal utility of consumption times what was the change in consumption per se. Okay, so that's the first unit. So we're looking at change in your utility along an indifference curve. Let's say point A to B, right? A to B. So how much did my utility change when consumption changed times change in consumption plus marginal, this fancy thing, delta F over delta L is the partial derivative of utility with respect to leisure. Fancy way of saying marginal utility from leisure. That's the change in your happiness when you change utility by 1 unit times how many units did actual leisure change. So I got great news. This change in utility along an indifference curve is fixed. This was like 25,000 units. A to B utility doesn't change. So change in utility is 0 units. Oh, great. Okay. Then what? So this is what we wrote down. And change in utility is 0 because along an indifference curve, utility does not change. Along an indifference curve, utility is constant, change is 0. Okay. So that's equal to 0. We are basically equalizing this guy to 0. All right, slope of indifference curve. So you can write marginal utility of consumption times change in consumption plus marginal utility of leisure times change in leisure is equal, it equals to 0. That's great. So rearranging this, right, just leave delta C and delta divided by delta L on one side because this is the slope of the indifference curve. Okay, so you can do this. I'm going to actually rewrite this, do that step here. Marginal utility of consumption times delta consumption, this is C, plus marginal utility of leisure times delta leisure equals to 0. I am going to send this guy to the other side of the equality. So you have marginal utility of consumption divided times delta C, divided is next time, equals negative marginal utility of leisure. I sent this whole thing to the other side, delta L. So I want to divide everything by marginal utility of consumption and delta L. I'm trying to get delta C over delta L in the left hand side. So these cancel out. On the left hand side you have delta C divided by delta L equals to, right, we divided both sides with delta L and marginal utility of consumption. This is C. Okay, delta L's cancel out. You have negative marginal utility of L divided by marginal utility of consumption. Okay, so this is exactly what we found. Slope of indifference curve is the negative of marginal utility of leisure divided by marginal utility of consumption. We call this marginal rate of substitution between consumption and leisure. So this is a negative number. Slope of the indifference curve is the marginal rate of substitution between consumption and leisure, which basically tells you how many units of consumption I'm willing to give up in order to get one more unit of leisure. Okay, so differences in preferences. So these are different kind of indifference curves. These are steeper, these are flatter indifference curves. These are two different people. Okay, and there are many more indifference curves here. This is person A, person B. So worker with steeper indifference curves, so this guy or gal, value their leisure relatively more than workers with shallower, flatter indifference curves. So this is shallower, flatter. These guys are, they are more like work lovers, workaholics. It's me. And these are a little bit more. So in order to let them give up 1 unit of leisure, look, -1 unit of leisure, these people require, check this out. So from A to B, from point A to B, to give up 1 more unit of leisure, you need to give them this much consumption, a lot of consumption, versus this person, A to B. Point A is somewhere here, point B is here, okay? For this person to give up 1 unit of leisure, -1, right? A to B, B is here. They only require just a little bit consumption. Just look at delta C. So this person, you want this person to give up leisure by 1 unit, move from A to B. They're like, you know what? You need to give me literally this much more consumption goods, versus this person to get 1 more unit. I'm okay with this much. So these are work lovers. They don't require a lot of consumption goods. And if you look at even the top part, 1 unit, let's say A to B, they require a little bit consumption. I'm just eyeballing it this much. Delta C. Look at this one. For 1 unit, okay, they don't even have low levels of leisure indifference curve presence. So you want me to cut down my leisure by 1 unit, you gotta pay me a lot. Look at this much. So this is different. So these are a little bit, I don't want to say it, but lazier people. These are more workaholic people. People who enjoy work. These people, it takes a lot to put them to work. Okay, I'll see you in part 3. In part 3, we're actually going to learn about budget constraints. Another reminder, folks, you need to watch all these videos in order. So a chapter, part 1, 2, 3, 4, go all the way to the end. And also don't forget to subscribe to this channel so you will get notified whenever there's a new video. I'll see you on part 3.